Okay, so for the reaction of an acid with water, I'm going to just represent any acid as HA, where H is the ionizable proton and A is whatever all the rest of it is. So just general is going to be an anion, right? So the acid plus base, so base is going to be water in this case, is going to ionize this acid. So it's going to donate its H plus to the water. So donating the H plus to the water is going to form the hydronium cation, and then whatever's left behind is the anion characteristic of the acid. So what's left after that H plus has been ionized? So you can take that same generic approach for any acid. So obviously, you need to be identifying your acid and base. Usually the clue for your acid is there's a hydrogen written on the front of it. Hopefully it's one of the acids that you recognize. So here we have perchloric acid. So to work out the anion that it's going to produce when it has given up its H+, we can see that must be the perchlorate anion. ClO4- is going to be the anion characteristic of that acid. So ClO4, if I could type, I can't type, minus AQ will be the anion, and the H plus that has been ionized is going to go towards forming hydronium. All right, so I guess we can look at a few others, just so you can get the general idea. There's only so many versions of this that we can really do. Let me just put this down here so you can remember what we did, and we'll go on to another one. Kind of short and sweet, right? All right, so this time we have HCl plus H2O. So what is the characteristic anion of our acid? Well, if it loses a proton, it's just going to give us the chloride ion, Cl minus. So that's going to give us Cl minus AQ. And then the H plus is donated to the water will give us the hydronium ion. Okay, so that's that one. Very quick, right? Liquid. Okay. I guess I can look at one more, see if we get anything more exciting. Probably not. I think they're all very similar. So chloric acid is going to be the same thing, right? The characteristic anion is ClO3-, so ClO3- AQ plus H3O plus AQ. So of course, just as a little bit of extra practice, you should always be thinking which bit's the acid, which bit's the base, which is conjugate acid, which is the conjugate base. So obviously, our chloric acid is the acid. Water is acting as a base in this case. And then our conjugate base is the anion that is formed by the acid giving up its H pluses. Conjugate base usually going to be an anion, okay? And then my conjugate acid, depends on what your acid is going to be the hydronium formed by the base accepting the proton. So always have that in the back of your mind, right? Which is the acid, which is the base, which is the conjugate base, which is the conjugate acid.